Welcome back to our AQA GCSE Computer Science series on computer systems, software, operating systems, and today we're going to cover off the rest of the roles. Last lesson we talked about user interfaces of the operating systems. We talked about the difference between hardware and software and the relationship between them, and also the two different classifications of software that you need to know about for GCSE: system software and application software. Let's cover off the rest of the functions of an operating system. This is a diagram really of a simplified operating system. At the center of the operating system is the kernel. This has low-level operations. This is dealing with hardware, dealing with interrupts, input-outputs, dealing with memory management, CPU management. Around the kernel sits the shell, and this is where the user interfaces live, GUIs, CLIs. And this operating system will also deal with the software applications. They'll be running different processes, so different programs run processes which the operating system deals with, and specifically the CPU will run different processes. We'll talk about that in a minute. You might be asking about examples of operating systems. Remember, try and avoid brand names, but if you do get asked about them, the most popular operating systems are Microsoft Windows, Linux, and Apple's iOS or Mac OS. Also on devices, there's the Android system by Google. A reminder for you, the different roles. So far we've covered off user interfaces, but now we need to cover off the rest of these. Now these sometimes are grouped differently. Sometimes they're grouped as security, which takes aspects of user and file management. Sometimes it's known as CPU management, which is where you're dealing with multitasking. And maybe I/O management, which is around peripherals and drivers. Let's talk about memory management first. As its name suggests, it's managing the memory, the main primary memory, random access memory, RAM. And it deals with the processes and programs that are loaded into main memory. Keeps track of each memory location, what's in that memory location, what process does that belong to, where is the process stored, how much memory does that process need, which process gets the memory. It's crucial that it manages the memory effectively. If it doesn't do that, then the whole computer will start to slow down. And one of the ways that could slow down is through multitasking of applications. Multitasking is part of the operating system. It allows the computer to run many applications at a time, also known as application management. And what it does is it loads a program into memory and then it runs it. And it's multitasking that allows you to do several things at once. Surf the web, listen to music while completing your homework on a word processor. The operating system then keeps track of which applications are open, what state they're in, where they are, what size the window is. If you minimize the window and open it back up again, it shouldn't lose any data. It's maintaining all of this information. But there is a limit. It can only handle so many processes, so many applications. The more applications you have open, the slower your computer is going to get because your memory fills up. So all these different applications need to be used at the same time, or have the illusion of being used at the same time, and the CPU is involved here. The operating system will allocate different processes to different CPUs if there's more than one CPU. Remember what a CPU is? It's a central processing unit. It's like the main part of a computer that does all the processing, the maths. How it multitasks on the CPU, so it just divides up the amount of time that each of these processors will be allowed to use the CPU. And it happens very, very fast. A bit like, think about a video. A video is just a series of pictures. But because they go so fast, you have the illusion of movement. And it's exactly the same with the CPU. The CPU will keep switching between different processors so quickly that it will appear that they're running at the same time. And the process of dividing this time up is known as scheduling or scheduling, depending how you want to pronounce it. Let's look a bit more into processes. Here's how a process is treated by an operating system. First of all, you create the process, it waits to be run, and then it will run. And it'll wait and run, wait and run, wait and run, and occasionally it will become blocked. And blocked is where it's waiting for something like, say, for example, a key press, user input. And eventually then you terminate the process. So it has three different states. The first state is the process is running. The next state is it's waiting to be run. And the final one is the blocks process, where it's waiting for something to happen. Next role is peripheral management and drivers. What are peripherals? All the things that connect to the computer. So these can be things that are physically outside the computer. Mice, keyboard, printers, joysticks, controllers. But in this case, it could also be drives within the computer that have to be managed with the inputs and outputs. Any devices that have an input or an output. So really it's controlling the interaction with all these devices that are linked to the computer system. And as you can see, there's a number of examples. So the operating system handles all the input and output from each of these devices. It sends and receives commands from whatever language they've been programmed in. There are different requests given by these devices and sent to these devices. A printer might want to use some time from the computer. These are known as interrupts. And it also includes network communication, because that also has inputs and outputs. So the operating system will deal with peripherals, which are network hardware as well. And that could be an internal network interface card. For all these devices to work, they need something called a driver. It's a software program. What that does, that sits between the processor and the hardware. It's almost like a translator. It allows processors to do things on hardware. And nowadays, nearly all devices come preloaded with the driver software that you need. You will need to update drivers as time goes by, but the basic driver that comes with most hardware is good enough to get you started. Let's move on to security. One part of security is user management. You'll be very aware of this because you've probably used a networked system to log in. And that is part of the security. They're managing the users. Who are you? Username. Are you allowed in? Password. Authentication, that's known as, but that's part of user management, security. Once you log in, it knows who you are. What can you access? What are you allowed to access? What are you allowed to run? You try and stick a USB stick into a computer, will it let you run that in case you try and introduce a virus? If you try and open up a program which you're not supposed to, it can control you and say, no, access denied, you're not allowed to do that. Go and get some permission. Another part of security is then the folders and the files. The file management role of the operating system presents data in a much more user-friendly way. Because as far as a computer is concerned, it's just a big block of data. It's happy enough to read it all because it's got different tables that tell where everything is, but for you to look at that, it'd be horrible the way it would just be listed in a raw form. So then they introduce nice graphical folders, put subfolders, present it so it's a bit more intuitive about where certain files are. And you combine that file management with user management, and it'll allow you to see certain folders or not. Allows you to do certain things in certain folders, like can you write to a folder? Can you delete something from a folder? That's all part of user management and file management. It's all part of the larger security operating system role. That's it, really. Go on to Edmodo, try the quiz, computer systems, operating systems. It's a long quiz, 60 minutes. To give you enough time to go through these slides, do some searching if you need to. Recap of this lesson. If we think about the previous lesson and this lesson, you've now done the operating system. As far as GCSE is concerned, there's an awful lot more to it, but as far as GCSE, that should cover off all the roles. You should know the difference between hardware and software, know the difference between system software and application software. What do you know about those keywords now? Memory, multitasking, peripherals, interrupts, drivers, file structures, file folders, that kind of idea. Should give you a better idea about using technology in the everyday world. Right, great. See you in the next lesson. Cheers.